well. If you are able to manage your cash, the fund properly, you are managing well. And third thing, in this part of world, India, because I see even operations across other part of world also, but India is quite unique. So you have a lot of compliance with respect to GST, TDS, income tax, and all those things. So three area is something is CTQ for me. Compliance is cash
Compliance,
management in the customer.
yeah, compliance, customer, cash. These are
Cash.
your priorities, not CTQs.
Yes.
These
Yes.
are
There are
your
priorities.
priorities, right? But
Yeah.
CTQs are measurable metrics. It
Right.
can be your cash conversion cycle, the period of your cash conversion cycle. It can be
Yes.
your inventory turnover ratio, or it can
Yes.
be, your the cost of goods sold.
Yes.
So I really, wanted to know such metrics. And the moment you identify certain metric and you are also able to understand you are not up to the expectation,
Okay.
you will realize there is a scope for improvement. That which is the
Yes.
first step in Six Sigma. You are studying Six Sigma as a step-by-step methodology here. The very
Yes.
first step is identifying the improvement opportunities.
Right.
But according to you, every project should align with any one of the three C. So
Correct.
these are called priorities. These are called your strategies.
Yes. Strategy.
Any
Exactly.
project that can attack any one of the C, you will be interested. But whether there is a project opportunity there or not, project opportunity is a improvement opportunity. Improvement opportunity is a gap in performance. The gap in the performance is the real problem, the pain that you are experiencing.
Yeah.
So this is what we call it as CTQ.
Okay.
Unless and until the CTQ is understood, understanding on the problem is weak.
Right.
The CTQs are not visualized and problem understanding is weak. You can't expect to solve it in a diplomatic manner.
Right.
So
Right.
that's a very, very, first phase, defined phase. That's what we have discussed. Thank you. Thank you very much
Right.
for sharing your products and CTQs. Rahul, what are your products and maybe one or two CTQs? Which
Okay,
you
I am currently enrolled in Tata Consultancy Service as a PMO specialist. So based on the based on the confidentiality thing, I won't be able to tell you much about the client of my project, but I would just say that it is generally into the engineering side, into the engineering domain, and we take and the client, they are into nuclear fusion, into the thermal nuclear fusion thing. So what my role is that as a PMO, I will take care. I have to know the entire system right from the sales cycle, then to the contract creation, followed by the contract creation, then the commercial management, then the delivery management and quality management. So I have to deal with all the team to make sure that everything is taking place in a smooth manner. And although as it is mentioned in our previous lectures, it is not it won't be possible to maintain a Six Sigma because of the budget thing. So basically we would be working in a Three Sigma or something like that. And apart from that, what I mostly take care is my main focus would be to ensure that if the resources are properly distributed to the proper employees, and if and also to at the same time we need to analyze what is the cost and what is the revenue that has been generated and cost that has been taken place in in within the manpower or within the other expenses and the miscellaneous expenses, and how it is, and how we can improve it later, and the budget which would be created for each task or each new projects, that we have to keep, we have to divide it in a proper way for the onshore team as well as for the offshore team.
understand.
And that also will take, so the main CTQ would be first and foremost, the numbers, like the revenue or the cost, optimum revenue and optimum cost we need to maintain. Second would be the timeline, that at what based on what are the The that at what time the the small task should be completed, and third would be the okay. Third,
Enough. Two is enough. Two is enough. Got it. I understood. So primarily your priorities are time and cost.
yes, exactly.
Time and cost, how resources are utilized, and whether everything is happening as per the plan or not. So you need to identify certain metrics. I do not know what are the metrics you look at. You might look at the lead time. You might look at the cost, delivery cost, or whatever, right? So there are certain metrics. These are called CTQ. This is what you need to understand. What is that you would like to see in your dashboard? This is called CTQ, critical to quality. Though it's a very lighter tool, unless and until we get into the core of it, we may not be able to understand how Six Sigma can be implemented in our workplace. So anyone else who would like to speak? Okay. But if all of you are switching off your camera, I will simply consider that none of you is interested in listening to me. Right. So anybody else would like to share something, or shall I proceed? I think in the interest of time, I'll proceed unless and until otherwise, somebody wanted to share the point. So I'm going to talk to all of you about two things. That's what is my role today. One is letting you understand capability analysis. Letting you understand capability analysis. What am I capable of? What is my process capable of? Which is very, very important, right? So unless and until you know how much capable you are, you can't predict. So the capability analysis. But before capability analysis, things should be under control. For example, we are also going to check your capability as a green belt. Check your capability as a black belt or a master black belt. How do we check your capability? We conduct examination. If you score a prescribed mark and above, you are considered capable and you will be given the certificate, right? But conducting the exam will make sense only if you have attended all the classes. Am I correct with my statement? Only if you have attended all the classes, only if you are going through the material, you are doing your part perfectly. Then only conducting the exam will make sense. If someone has not at all attended any class, not participative, do you think conducting the exam will make sense to that candidate? If at all he is passing, it is by hinky panky. If at all he is failing, it is already known. So in my opinion, better don't conduct exam for such people. First of all, make them go through your process. First, ensure a process is in place. First, ensure your own process is under control. If the process is under control, then only you can proceed to the capability analysis. This is the primary reason we require a tool called control chart. A tool called control chart. A control chart can let you understand whether your process is under control or not. If it is under control, we conclude that the process is stable. If the process is stable, you can proceed and check its capability. If the capability is not up to the mark, you can move on to the next step, which is called process improvement. You already attended the green belt, already attended black belt, and now you wanted to improve yourself further. You can now take measures to improve your knowledge level, skill level, to go to the next height. So similarly, once the process is under control, you can improve the process. So there is a clear difference or a boundary exists between process control and process improvement, right? So process improvement, you have DMAIC, define, measure, analyze, improve, and control. And then we check the capability. The capability is not up to the mark, we improve the capability. But prior to all these things, you must ensure your process is under control first. Right? If the process is under control, you can consider it for improvement. If it is not under control, your primary job is bring it under a state of control. We also call it statistical control. We also call it stability. So what is this statistical process control? How the control chart is helping us? The terminologies, used in the field of statistical process control. That is going to be the first session. And then towards the end, I will tell you how to conduct the capability analysis. And then we will also measure the capability in terms of CPCPK or PPPPK, according to the requirement. So this is going to be my talk. Differentiate between common cause variation and special cause variation. Common cause variation and special cause variation, and how to plot control chart for variable data. I'm sure all of you by now, you have a clarity on what is your variable data, otherwise called continuous data. There is one more type of data called attribute data. You have different set of control charts, one set for continuous data, one set for attribute data. I'll throw light on it. And then how to plot control chart using Minitab. Because Minitab is user friendly. In no time, you can plot control charts. All that required is data collected in the appropriate format. And then we'll also see certain example cases where we'll also see plot and interpret the control chart for deduction of special costs. After plotting the control chart, we need to interpret it. We need to draw a conclusion whether the process is under control or not. So how to interpret? Depending on the points that are getting plotted, you can make meaningful conclusions, right? How that is going to happen. So this is how typically a control chart will look like. Hope all of you can see three lines, horizontal line. A center line, which is in green color, and a line above, which is in red color, and one more below, which is also in red color. Can you all see all the three lines?
Yes.
Yes, sir. Yes.
The red color lines are called control limit. These are like the boundaries, India-Pakistan boundary. If you cross, critical, something serious. Similarly, if a point goes beyond the red color line, you should not keep quiet. Isn't it? Why this fellow has come out? Why this fellow has come out? You need to start thinking. You need to start investigating and do everything to ensure that fellow stays inside the red color line only. If you are able to ensure every single point is inside the control limit, you can safely conclude your process is under statistical control. Otherwise, process is out of control. Because someone cannot easily cross border. I hope all of you agree with me. Similarly, your statistics can fluctuate. Please understand, your statistics can fluctuate. You can see the fluctuation in the blue color graph. Am I right? Your statistics can fluctuate, but not to the extent of crossing the boundary. What is the boundary called? Control limit. Upper control limit, lower control limit. What is the central line? Central line is the central tendency of your data. It is mean in this case. It is mean in this case. You can see X double bar. Average. So now, can one of you answer me? What will be the distance of the red color line from the green color line? Do you have any idea, any clue out of your participation in the program so far? What could be the distance of the red color line?
About 3 sigma.
Exactly. Exactly. It is 3 sigma. 3 times standard deviation. If a point is 3 times standard deviation away from the center line, it should be considered an out of control point. Right? You can miss the target. You can miss the target by 1 standard deviation. You can miss the target by 2 standard deviation. You can miss the target by 3 standard deviation. If you are missing the target by more than 3 standard deviation, you are not stable now. Can you make out?
Yes.
If you are trying something, it is quite natural that you can miss the target, but not to the extent of 3 sigma units away from the target. If you are missing 3 sigma units away from the target, this is something, telling you that the work is going on in an unprofessional way. Right? So that is why we must alert ourselves and bring the professionalism by controlling the process, by ensuring that every point is staying inside the control limit. So with that note, why control chart? You can monitor stability. You can determine readiness for improvement. Readiness for improvement means Shall I do capability analysis? Please do the capability analysis if process is under control. You can allow the consultant to come inside your company only if your processes are stable. If the processes are stable, then the consultant will also work like an employee. He will also work with you, sit down with you, only to ensure you standardize the process. But if you really want improvement, engage some experts, do it after ensuring the stability in your process. Hope everybody understand my second statement. Determine the readiness for improvement. When to engage an improvement initiative, or engage some experts, or engage ourselves in an improvement activity, only when your process is under control. If you yourself are not ready to learn new things, you will never learn. That is the message coming out. If your process itself is not ready for improvement, any effort you put, that will definitely fail. So, third point, demonstrate improved performance. You can use the control chart to tell someone that you have significantly improved. Look at the control chart before my project. Look at the same control chart after my project. Do you think people will be able to understand the improvement that you achieved by looking at a graph? Definitely. Before the project, points were outside the control limit. Points were far away from the center line. But now, after the project, all the points are inside the control limit. Moreover, the control limit itself is too close to the center line. You understand my language now? Earlier, control limits are far away from the center line. Points are also outside the control limit. But now, after the project, points are inside the control limit. And the control limits are also close to the center line. Can I consider these observations as improvement?
Yes, sir.
So control chart can be used as a visual validation tool. You can quickly convince the top management just by showing them a control chart, which is called before after control chart. You can use this ideology to validate your improvement in the improve phase. So the tools are non-linear, which means whenever required, you can use them. Now, in the control chart, in statistical process control, you need to understand the difference between common cost variation and special cost variation. All of you, first of all, are you comfortable with the term variation? All of you, are you comfortable with the term variation? Variation is good or problem?
Variation is a problem, not a
Yeah.
good. Because if variation will be differ from mean line, so it may be a possibility to occur major causes.
Yes. So variation is a problem in business, right? Except exceptional cases. Suppose if you are a batsman playing cricket, right, and the bowler is coming up with a lot of variation in his balls, now it becomes difficult to manage, isn't it?
Okay.
Similarly, you produce products and the dimensions comes with a lot of variation, and now customer is going to shout at you, what is this, right? And every single product is different. So these are problematic areas. And the exceptional cases, you are going for a buffet dinner. Now there is a lot of variety. There you like variation, isn't it?
Yeah.
So you have 20, you have 20, 25 varieties. Then you really enjoy the food. So mostly in business, variation is a killer. That will pull down your consistency, and later that will also pull down your capability. Initially, it will pull down your consistency. Then if you allow it, it will become inconsistent to the extent that it can even make you incapable. So the foundation for capability is consistency. Consistency is the key. Even if you are not good at something, if you are consistently doing it, eventually you will become good. All of you agree with my statement?
Yes, sir. Yes.
Right?
Yes.
You are not good at singing, but every single day you are singing in your bathroom. One day you will start liking your own song, isn't it? So that is the secret behind consistency. So control chart is checking your consistency, checking your stability, checking your statistical control. In order to understand what is consistent or what is inconsistent, in order to draw a boundary line between consistency and inconsistency, you need to understand two types of variation. One is common cost variation, Another one is special cost variation.
Sorry
Common
to interrupt,
yes,
sir.
yes,
Sorry to interrupt you.
please.
So, like, since you have brought this example about the barbecue nation, that the buffet system that we get in the barbecue nation. So, I believe, okay, we do like the main reason of like the USP of this barbecue nation or this such kind of buffet restaurants are that we have varieties. Like they will provide you variety at a particular amount, but still within that variety also there will be some consistency they would want to maintain.
Agreed.
Can you
Agreed.
just
Correct.
explain us that part?
Agreed. Agreed. Correct. So as far as the biryani is concerned, biryani should give the consistently good taste. That's your point. I agree.
Okay.
Right. But between your biryani and what you call the desserts, yes, there that difference is actually the variation which actually gives pleasure. I got your point. You're right. And that's just an example, not to worry. So
Okay.
common cost, special cost, there is a boundary we need to draw. So common cost variation is also known as random variation. Because we do not know why the variation comes. It is also known as normal variation. It is also known as unassignable cost of variation. Why it is unassignable? If somebody is asking you, why is it happening? You can't. You can't fix it because nature has its own rule. Hope all of you agree with me. We can't go to the extent of controlling the nature because God has created the nature in a way that there is certainty, there is also uncertainty. Isn't it? So certain things you can't control. We think every single day is exactly 24 hours, but actually it is not. You can never fix it. Isn't it? So certain variation, we have to live with it. What is that called? Common cost variation, otherwise called random variation, otherwise called normal variation, otherwise called unassignable cost of variation. Hope all of you agree with this. The exact opposite is called special cost, non-random, non-normal, assignable cost of variation. Imagine all of you are going to office by motorbike. You are going to your office by motorbike. On an average, it takes 40 minutes for you to reach the office. And I'm just recording your travel time for about 5 days. And now I get this data. I end up generating this data. Now tell me, is there a variation in my data? Is there a variation?
No.
Common cost of variation.
So if I ask you, is there a variation? Yes, variation is there. You can see there is a variation, isn't it? 40, 42, 38, there is variation.
Yes, sir, it is variation.
Variation. My next question to you, is there a specific reason for the variation?
No.
I'm asking you, imagine you have produced this data. I'm asking you.
I think it's a traffic jam. There is a possibility.
Just 1 minute delay or 1 minute early, you came and you are able to correlate to the traffic? Or even without the traffic, still this can happen. Am I right?
The way you drive.
That means
Maybe we started maybe there is very start time from our home. Maybe we have started late, or sometimes we started late, or sometimes we started a bit early. So this.
see, my point is there is variation, but then if somebody is asking you why variation, you can't tell a reason. Even if you tell a reason,
We cannot control the variation.
yeah. Yes, correct. Even if you tell a reason, it can be correct, it can be wrong. Do you understand? If you say, sir, it is due to traffic, but actually it may not be due to traffic. You might have applied, the brake too many times on the way. It can be that way, isn't it? So you can't confidently say, sir, this is the reason for variation. That means the chance is random. You get me?
Yes, sir.
Because if you can specifically find out, you can fix it. And then next 5 days, you can make it exactly 40. You will never make it exactly 40 for continuous 5 days. Am I correct with my statement?
Yes, sir.
Even if you try to reach office in exactly 40 minutes, will you reach in 40 minutes? It will be 40 plus or minus, right? So that is why it is called common cost variation. Another week, another day, I noticed that you have reached office in just 25 minutes. I'm coming to you again. I'm asking you, Gentlemen, how could you reach your office in 25 minutes today? Now tell me, will you have a solid reason now?
Yes.
Yes, sir. I followed another route. Generally, I come through route A, but today I came through route B. Or another reason could be today is a holiday. Road is completely free. What I normally achieve in 40 minutes, today I achieved it in 25 minutes. Now you are able to explain the reason for the variation. The moment you are able to explain the reason for the variation should be called a special cause. All of you understand?
Yes.
Yes, sir. Yes.
Now another day, you took 55 minutes. Similar situation. Only thing is this time you are late. The previous time you were early, but now you are late. And so this is a common cause or a special cause?
Should be special.
This may be a
Should be
yes.
special. Should be
Yeah.
special. And now there is a rain on the way. You have to slow down and you have to come late by 15 minutes. One another day, you took 1 hour 40 minutes. Is it a common cause or a special cause?
Special cause, sir.
Again, special cause.
I'll consider this as very special because you have met your girlfriend on the way. So you decided to spend 1 hour in the coffee
Yeah.
shop. And that's how it is, 1 hour 40 minutes. So all of you now understand the difference between common cause and special cause. Clear? If
Yep.
the point what you see is away from the center line, which is average, 40 minutes in this example, it is special cause. If it is close, then it is common cause, right? So this is common cause, this is special cause, this is very special. So you can classify common cause and special cause in several manners. Suppose if you are a banking professional, right? And your customers signing like this in the checkbook, will you pass all the checks? Will you pass all the check? There are 3 checks coming and 3 signatures. Can you see some variation? Yes or no?
Sir. Yes, yes.
But still, I would like to pass all the check. But the other case, the signatures are like this. Now I will probably stop the payment. Do you understand?
Yes, sir.
Because it is special case, right? So we need to understand. Similarly, the control chart is used in what you call.
Now he's gone up in a field again, is it, Gidi? There it is.
Control charts are used in cricket also. Can you see? They are checking whether the ball has hit the bat or not.
Yes, sir.
The moment the ball hits the bat, can you see? Notice some peak.
Yes, sir.
And the peak is giving us an information. What is that information? Yes, the ball has hit the bat. And so the batsman should be given out. Even if the ball is not hitting the bat, still there is a variation, isn't it? Natural variation. The air molecules will move up and down. Random movement. We also sometimes call it Brownian movement. It just moves up and down. But the up and down, the amplitude can suddenly increase if something special happens. Similar kind of signals will definitely come from your business process also. You should be capable enough to understand, yes, the signal that is coming to my table is now special. If it is special, you should no more sit in your table. You must move to the place where the data is collected. You must do some investigation because the cause is special cause. Hope all of you agree with me.
Yes,
Right?
So I have one question again. Like,
Yes.
in order to determine if it is a special cause or a common cause, so generally we will have to use more than one tools, right? To just get to know that this is a special cause or
A good question. Good
common
question.
cause.
Good question.
Because here also, since you have given me the ultra H example,
Very
even
good.
if you will see the and actually I was about to bring the point you have already brought about the air molecules movement, because based on that also there will be showing some variation over there. But that won't but based on that we can't go for it, right? Then we will just go with the visuals, right? Then we'll just see if it is nearby or something. So
I agree. See,
here we are using two tools.
whether one reason is enough or one what do you call, one kind of signal is enough or not? That is your point. Definitely there can be no different forms of signals, right? But it all depends on the maturity level about your process, which is called process knowledge. Suppose, let us say you want to control your children. You want to control your children. Will you apply only one condition or you apply many conditions?
Yeah, more than one condition. Many.
You put lot of conditions, isn't it? But if your child is not at all listening to you, you will apply only one condition. Hey, please go school on time. You can't go talk about the next, isn't it? First, you go to school every day. The child starts going to the school every day. Now you will add on the second condition. Are you learning? Do you understand? Now the second question is, are you learning? Are you attentive in the class? Now the child has become attentive. Now you will start asking about the marks. You get my point? Marks, 60 marks. Now you will start asking about 80 marks. All of you, do you understand? How do you keep adding conditions?
If our short-term goals are achieved, then we will.
Yes, right. It's like, we should have the knowledge about the process to the extent that we could understand whether the problem is due to the natural cause or the problem is due to the special cause. Whether the child is denying to learn or the child is not able to actually perform. If she is denying to learn, then you will definitely put some conditions, isn't it? But not able to learn, you will help her, which is called improvement, right? So you will definitely come to know about that. There are a lot of conditions, many conditions you can look at to classify whether a process is under statistical control or out of control. But right now, first condition, very, very first condition is, are you going to the school or not? Are you sitting inside the classroom or not? Are your points are inside the control limit or not? That's the first condition you need to check. The control limit I have drawn red color line. Since at a particular point, the what do you call, the amplitude has gone above the center, red color line, the umpires have concluded that it is due to special cause, and then the conclusion is ball has hit the bat. Same way we will be using it in the business also. Now, two types of variation: common cause variation. A process that is operating with only chance cause of variation is said to be in statistical control. And a process that is operating in the presence of assignable cause is said to be an out of control process. For an out of control process, never conduct capability analysis. Never conduct capability analysis, right? So conduct the capability analysis only when the process is under control. Ensure the stability. This should be your primary focus. Stability means all the points should be randomly distributed within the control limit. If stability is ensured, think about capability. And you can improve the capability. You can improve the capability. Improving the capability means you can even try to bring the control limit too close to the center line. You are making your process, you are putting stringent conditions to the process. Where it will reflect? It will reflect in the position of the control limit from the center. And also, you can try to move the mean wherever you want. Suppose if it is a profit which you are monitoring in a control chart, you can move the center line completely upward. If it is the cost of poor quality or if it is the rejections, you can try to move the center line completely downwards. So moving the center line upward or downward, or moving the control limit towards the center line, are nothing but process improvement projects, are nothing but the Six Sigma projects, right? And so the capability can now be measured in terms of sigma level, in terms of CP/CPK, in terms of yield, in terms of PP/PPK, or any other metric that you want to measure. In my opinion, all are same. You must have a deeper understanding to understand that all are same. You look at sigma level, you look at rejection rate, you look at the yield level, you look at the DPMO, you look at the PPM, you look at your CP/CPK, you look at your PP/PPK. All of them are finally, landing at the same point, right? So higher the sigma level, higher will be the capability. All of you are with me so far? Please confirm. All of you, are you with me so far?
Yeah.
Yes, sir.
Yes.
Very good. Right. A process which is under statistical control will have. What is your answer here? Come on, you need to answer now.
Normal variation.
Normal variation. Normal variation.
All are correct.
All are correct.
All are correct.
Common cause, random variation, normal variation, unassignable cause of variation. These are all same words. So answer is all are correct.
Okay.
An out of control process will always have special cause, common cause, both. What is your answer?
Special cause.
An assigned cause variation.
Option 3, sir, both common, common and assignable cause.
Beautiful. Option 3 is the correct answer. Because at any single point of time, normal variation will be there. At any point of time, normal variation will be there. Since the process is out of control, special cause will also be there. So option 3 is the correct one.
Sir, can I come?
Yes, sir.
So can you differentiate between normal variation and common cause variation? Sorry to interrupt.
Any observation beyond control limit is special cause. Any observation below control limit is common cause.
And
And
what is
further
the difference between
understanding-
normal variation and common cause variation?
Sir, can I come?
No, normal variation and common cause variation, I am saying it is same.
Okay.
Yes, sir.
Sir, can I come? Sir, I just want you participants to note that one important thing, that in this course, you are going to develop yourself. And I will tell you what is the weakness you had and what is the strength you got right now in these two questions by Dr. Shivakumar. When he was asking this question, first question, there were 5 options and you were saying that normal variation. Why did you answer that normal distribution, normal variation? Because it has been taught by Gopal Shivakumar to you on normal distribution. Therefore, you have said that the answer is correct. And the answer is correct. What is that you forgot to do? You forgot to analyze what are all the other terms involved in the 4 other options. Common cause variations. What does it mean? For that, you will have to apply your knowledge, general knowledge, smartness, right? Oh, common cause variation and normal variations are same. Random variation is same. Unassignable causes means that we cannot assign any causes. Only if we can assign, we can rectify. If we can't assign, how can we rectify? Therefore, it is only a normal cause variation. We have to live with that. It is God-given variation. Friction. Friction is given by God. We'll have to live with friction. If the friction is not there, I cannot reach my house. I can't go to my house and stop there. Right? Therefore, what you forgot to do was that you forgot to analyze the rest of the things. But then what happened? He gave you the answer. He gave you the thinking process. Hey, I have to think the other things. Then the next question when he was asking, you apply the thing. What you observed, what you learned just now, you have applied. This is how children grow, and we also grow. So we will have to keep that all of us are children, including Gopal Shivakumar and including RK. We are learning together. While children are learning, what do? One important aspect is they shed out their shyness. They are not shy of asking questions. They are not shy of giving wrong answers. They are not shy of giving wrong speeches. They understand, because even there is a grammar mistake, they understand. Similarly, here also, I want you to do that. Answer. Because I have seen that Megha, Gisman, James, and one more gentleman flickering there. That means you are trying to answer, but you are not coming out with the answer. Thinking that your answer will be wrong. Yes, your answer will be definitely wrong. Because that is where we win. No. Everyone is ego. We want to win as if we know something which you don't know. Actually, the other way. We don't know many things that you know. Right? And we are learning that. Please have this in mind. Participate, answer the questions, even if they're wrong. You will learn much more than what we teach you. Thank you very much.
Right. One more questions for your thought. We can improve the result of a process, even if the process is statistically out of control. How many of you consider this statement as true?
False, sir.
Should
Chanchal is
be
here.
true.
Yeah, it is false, right? Now the goal should be stabilized.
Yes.
Goal should be stabilized.
The first important thing is that process should be is in under control.
Yes,
Yeah.
exactly. So if the process is statistically out of control, there are 2 possibilities. One is stabilizing the process. Another thing is improving the process. Our immediate goal should be statistical process control, right? Then if everything is under control, go for the next stage, which is statistical processing. And now let us understand how to plot a control chart. And as I already mentioned, there are two types of data. One is continuous data, another one is discrete data, also known as attribute data, right? So continuous data means measurable. It will have a dimension. For example, what is tabulated in my slide is length of a product. Tell me, all of you, length of a product, will it have a dimension? Length of a product, any physical dimension? How do you measure the length?
Centimeter, meter.
Centimeter, millimeter. The moment you are able to see centimeter, millimeter, kilometer, the data is continuous. All of you are with me?
Yes.
Right? So it is measurable. So it is continuous data. And for continuous data, you can go for control chart for variables, because sometimes continuous data are called as variable data. And now look here, how the data is collected. Data is collected on for how many days? 5 days. Day number 1, day number 2, day number 3, day number 4 and 5. And every single day, how many shifts are there in the company? 4 shifts.
Four shifts, sir.
And every single shift, you are the person collecting the data.
5%.
How many data you are collecting? 5.
5.
The 5 is now called subgroup size. The 5 is now called subgroup size. The number of days are 5. Every single day, the number of subgroups are 4. And every single subgroup, the subgroup size is 5. All of you understand my language?
Yes, sir.
There are 5 days. There are 20 subgroups. And in each subgroup size is 5. So the total number of samples is 100. Now the relevant control chart is X bar R chart. The relevant control chart is X bar R chart. The reason for choosing the X bar control chart is X bar R chart is, one reason is data is continuous. Another reason is subgroup size is less than 8. Whenever subgroup size is less than 8 and your data is continuous, you must plot X bar R chart. All of you agree with me?
Yes.
Yes. Now, how to plot control chart? There are certain steps. These steps you can easily learn. You can go through the slides. Look here, everything I have written. So how to collect the sample, calculate the average, and calculate the range, and control limit. There are certain formulas. I'm not going to explain each and everything. You can just read through. These are formulas and the steps. And finally, in order to calculate the control limit, you require statistical constants. The statistical constant depends on the subgroup size. And your subgroup size in this case is 5. And I require 3 constants, A2, D3 and D4. A2 is chosen as, chosen from the table, 0.577. D3 is 0, D4 is 2.114, right? And this table is available in the Google. It is there in the manual, which I have shared. You can go to that appropriate page and then go along the subgroup size of 5. You will be able to pick up all these constants, right? So A2, with the help of A2, D3 and D4, you can locate control limit. And now how? I have all the data. Now I have organized the data in a table. Now this is X bar. Can one of you tell me how to calculate this X bar? How to calculate X bar?
Mean of X1, X2, X3, X4, X5.
Beautiful. Just add all the 5 data in your subgroup, divide by 5. This is called subgroup average.
Yeah.
You have 20 subgroup, you need to calculate 20 averages. This is what I am trying to monitor, because this number carries an important information to me. Another metric I want you to look at is range. What is range?
Range is the maximum difference between maximum to minimum value.
Beautiful. The maximum in subgroup number 1 is this one.
Yeah.
Minimum is this one. And so the difference is 3.6. This is called subgroup range. First subgroup, range is 3.6. Similarly, you need to calculate for 20 subgroup. All of you will be able to do it.
Yes.
This is subgroup average, this is subgroup range.
Yes.
20 average, 20 range. Now I want you to calculate the average of the average.
Yes.
Average of the 20 average.
Average of
also-
the, sorry for
Yes.
interrupting, average of the average is called double X bar.
Exactly, X double bar. That X double
sorry.
bar is your center line in the control chart.
Okay.
Everything is significant to us. If you understand it very clearly, I'm sure all of you will start using control chart in your current job. Now R bar is average of the 20 ranges. Average of the 20 ranges. Now you need to plot the control chart. Now the control chart is called X bar R chart. Should I plot X bar chart first or should I plot R chart first? You should plot R chart first. Take a graph sheet. I hope all of you remember you are advised to bring a graph sheet, right? This is the purpose. You all have to do it manually. And then the graph, whatever you generate, you can post it in our WhatsApp group, right? Just for verification. So now you have a graph sheet and the range chart you need to plot. The center line for the range chart will be R bar. You have the R bar value. How much is the R bar? 2.72. You see here, 2.72, I have drawn a line. Now upper control limit, formula is D4 into R bar. What is D4? 2.114. So D4 into R bar will be 5.751. Draw the upper control limit. Lower control limit, D3 into R bar. D3 is 0. So lower control limit is 0. So draw the lower control limit. Now center line is available. Upper control limit is available. Lower control limit is available. Plot your first range.
Sorry to interrupt. Can you just explain how did you get UCL?
UCL is formula is D4 into R bar. Can you see the formula here?
Okay.
D4 into R bar and lower control limit D3 into R bar.
Okay.
Right? These formulas are developed by the statisticians and we are just using it because what we require to locate the control limit is population standard deviation. What we have is only sample. From the sample, how can I go close to the population standard deviation? So you need to convert the standard deviation of the sample into standard deviation of the population. For that, we have some moderations in the formula using constant. So D4 into R bar gives upper control limit, D3 into R bar gives lower control limit. Now the control graph is ready. First range, second range, third, fourth, and so on up to 20.
D3
Now
and
tell me.
D4, they are given.
Yeah, D3 and D4 are given. A standard table is available. The D3 and D4 depends only on the subgroup size. Now our subgroup size is 5 and so D3 is 0, D4 is 2.114.
What if D3 and D4 are not given? Then how will we find out?
No. These are available.
Okay.
These are available. Right now also you can Google it. Just type control chart constants. You will now see various values of D3 and D4 for different subgroup size. Generally, people take sample from sample size of subgroup size of 1 to 25. From 1 till 25, the table will be available, right? I will also show it, don't worry. Now look at the points. Look at the points. Tell me, is this process, is this control chart under control?
Yes.
Yes, sir.
Yes.
All the points are inside the control limit. Only one condition I want you to check. Just check whether the points are inside the control limit. Yes, all are inside the control limit. And so the range is under control. Now, one of you tell me, what is the important information the range is carrying? How are you going to make use of the range? Can one of you tell me? Come on, please. How is this range is making sense to you?
The standard deviation is low over here. Less standard deviation.
Very good, very good. Less standard deviation. I agree. Let me go to the data so that you can think better. Look at the data. Now tell me, what is this range is conveying you?
Maximum minus minimum.
Maximum minus minimum. See, we are doing the training for 3 weeks. Am I right? 6 days.
Yeah.
Your learning should be good on first day, second day, third day, fourth day, fifth day, sixth day. Am I right?
Yeah.
Every single day your learning should be good. And within day one, we have got different sessions. Am I right?
Yes.
Do you want to learn well in all the session inside every single day? Yes or no?
Yes.
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 Now look at the
Yes.
data. Shift number 1, how many products you produced? Several thousand products,
Yeah.
but you have taken only 5 samples. With the help of the 5 samples, you are trying to judge on the 1,000+ products you produced. Am I correct?
Yes.
If 1,000+ products all are good, the variation will be less. Am I right?
Yes.
So the range calculated using subgroup number 1 will be less if the products produced on day number 1, shift number 1 is, very consistent.
Okay. Yes, sir.
If the variation is less, all the products are, close to the target. If
Yes,
the
sir.
variation increases, there could be lot of bad products that are produced on shift number 1. I don't want my company, my team to produce lot of bad items in every single shift. So how do I control it? I can't literally check each and every product, but I can definitely keep an eye on the range. The range is called within subgroup variation. You can also call it as within shift variation. If the within shift variation is 0, your product is, the best. I mean, all the units produced are exactly same. If one is acceptable, all are acceptable. Do you understand?
Yes,
If
sir.
the range is 0 and if one product is seen good, it simply means all are good. Do you get my point? So lower the range, more the consistency. So that is why I look at the range. And I could see my range is completely under control. It means my process is going good with respect to the variation within every shift. The first shift variation under control, second shift variation under control, third shift variation under control. So if I select small sample, the sample can be considered a representative of the, every unit that is produced in the particular shift. All of you are with me?
Yes, sir.
This is called within batch variation. Within batch variation is under control. If within batch variation is under control, you can proceed to plot X bar chart. This is carrying another important information. And now how to plot it? Center line. Center line is nothing but X double bar. You all know. And upper control limit is X double bar plus A2 into R bar. For a subgroup size of 5, A2 is 0.577. So use A2 equal to 0.577 and the X double bar value and the R bar value to get the upper control limit. Because what is the formula? X double bar plus A2 into R bar. Similarly, X double bar minus A2 into R bar will give you lower control limit. So I have drawn the upper control limit, lower control limit, everything is available. Now, what is that I will monitor here? Subgroup average. First subgroup average under control. Second subgroup average under control. Third subgroup average, fourth, fifth, sixth, so on. Now everything is plotted. Now look at the graph and tell me, is that the subgroup average going well?
Little variation.
No.
Going well. Except,
1.
what is that? Eighth day, there is a problem. You can understand. When I plot the control chart, I can see 8th day there is a problem. Now, since the subgroup average is out of control, now tell me, you have produced several thousand units on shift number 8 or shift number 4, day number 2. Now, all the 1,000 units you produced, will you send it to customer or you will hesitate to send it to customer?
Hesitate.
Hesitate. Because you are doubtful now, because the average itself has moved out. See, it is not one single point going out of the control limit. The average itself is going out. It has gone out to the extent of going beyond control limit. And now you have become hesitant. You will tell the dispatch manager, to stop the dispatch. Am I right? That's the first step you need to do. All of you, do you understand now? First thing you all have to do is you must advise the dispatch manager to stop the dispatch. Agree, all of you?
Yes, sir.
Yes.
And now what is your next step? You have to do 100% inspection.
Yes, sir.
When you are stopping the dispatch, what you are doing is problem containment. You are not allowing the problem to go to the customer. Now you are doing 100% inspection. After doing 100% inspection, the good ones and bad ones are segregated. Only the good ones will now be dispatched. So now your customer is safe. Am I right?
Yes, sir.
Now your customer is safe. Now what will you do next? You must investigate what went wrong on ship number 4, day number 2. Go to your data collection sheet. Who has collected the data? Who was the operator? What was the machine? And what was the machine setting? Supplier, raw material supplier. Look at all possible details, whatever you have captured, and look for the abnormality. You get my point? Look for the abnormality. And yes.
Sorry for interrupting. So it is a process of RCA.
Yes, definitely.
Yes.
That's what I'm saying. So you need to do a root cause analysis for this. If you don't fix it, the problem can get magnified at any moment. Most of the time, the tendency is people ignore, assuming that this is one point. But one point represents one lot. If you send that one lot of product to the market, to the customer, then you will realize the significance of this one point. Agree? All of you agree with me?
Yes.
So, root cause analysis must be done. Otherwise, every single day you have to do 100% inspection. So, the first graph, we monitored subgroup average. In the second graph, we are monitoring, first thing, subgroup range. The previous one is
UCL X bar and LCL X bar. How you find that 601?
I come to that. So this is our chart we monitored, which is called the subgroup range. And then we monitored the X bar chart, which is called the subgroup average. Significance of subgroup average is understood. Significance of subgroup range is also understood, right? And the formula is, I told you, you can read the formula. Upper control limit is center line plus A2 into R bar. R bar you have. A2, you can get it based on the subgroup average. In this case, it is 0.577, right? I'll give you the table. I'll pass on the same data, same exercise to each one of you. You all have to do it manually once, so that then only you will understand, right? So you pick up the value from table, calculate yourself manually or in an Excel, and then plot the graph, and then you will be, happy about your problem. No?
So this bar is connected, similar, is it the extended version of the previous graph, or this graph is a different one?
This is different one. This is different one. Look at the center line. Center line is here X double bar. Center line is X double bar.
Okay.
The values are different. Now I am showing both. R chart also I am showing. X bar chart also I am showing. And
actually, sir, one more question, here in this chart, we got to know that there is one there is one output which is crossing, which is extending beyond the LCL. So in that case, if we according to the Six Sigma, it should be the defect should be of 3.4. So it is going, there is only one output which is exceeding the line. So in that, do you think that in that case also we should go for
no, you are now thinking in the wrong direction. First of all, you are not checking capability here. Please understand.
Okay.
For capability, you need to know specification limit. Specification limit nowhere appearing. What is appearing is process control limit. Another thing is, I already explained, this is not 1 point out of 20. This is not 1 point out of 20. This represents 5 samples out of the 5,000 unit you produced. Then only you will understand the significance of the point.
Right.
Don't see this
Yeah.
point as 1 out of 20.
Yeah.
According to the graph, it is 1 out of 20. But the reality is, it is representing 5 samples,
5 samples. Yeah.
which you collected to represent 5,000 units you have produced. Now this point is not, less significant one. This is definitely an important one. You understand?
Okay. So specification limits we will get to know from UCL and LCL. From this only we will get
No.
to know
Specification limits will be given by the customer.
customer. Okay. Fine.
This should have been taught to you on day number 2.
No, yeah, I got it. Okay.
Yeah. Control limits calculated from the process data. That's how I am showing. But specification limit customer will give.
Exactly.
If the customer says gives the control limit, specification limit above the control limit, then you should be proud now. If the upper spec is here, lower spec is here, your process is capable.
Sir, can I come?
Suppose if the upper spec is here, but lower spec is here, all these you are producing here will now get rejected. So unless and until you place the specification limit, you can't comment about you can't comment about capability. Till then, we are only commenting about statistical control.
R chart, it is passed, and X bar R chart, it is failed.
Yes, come again. I'm not able to listen to you. Yeah.
R chart, sample range chart, R chart, everything is in UCL, within the UCL and LCL. But X bar R chart, one value come out of LCL for the same data.
R chart, everything is under control. But X bar chart, the 8th subgroup is out of control. So on 8th day, that is 4th shift on day number 2. That is why I told you to stop the dispatch. I told you to do 100% inspection. I told you to investigate the process. I told you to readjust the process. Then only you should continue with the next shift.
What is the difference between X bar and R chart?
R chart. Okay. Tell me.
X bar.
Okay. This man James.
Sir,
Tell me,
sir?
sir.
Can I come?
Yes, sir.
Please note, you are having 3 students and then you are having 100 students in another class. Your approach to the 3 students will be different. Your approach to the 100 students class will be different. Yes or no?
Yes, sir.
Yes.
For the 3 students, you can find out the difference between them. That's all. Simple. But in the 100 students, you can't find out the difference between each and every student. Therefore, you have to take an average and standard deviation. Here, you just take the range, first student and third student, whichever is maximum. Understood? And then you are asking something about the how it is affecting and all. Imagine you are going to a dinner, you are going to a marriage, and then you are tasting the food. In sambar, the salt is too much. If the sambar is too much for you, please note, will the salt will be too much for everybody or not? Yes or no?
No.
It will be for your batch, for the next batch people also. Yes or no? So what you should do, if the sambar is salt is too much, immediately you go and complain. Then he will make arrangement, put water or whatever be it, so that this is out of control point, and then you will have to take immediate action so that all the batch is not affected. You are not saving a loss. Thank you, sir.
All right, James. Tell me, what is the product you deal with?
The stabilizer and inverters.
You are stabilizer, an inverter. Let us say you are manufacturing stabilizer.
Yes.
You produce the stabilizer in a lot, and the lot of stabilizer is sent to Chennai. And now in Chennai, let us say 1,000 people buy your stabilizer.
Okay.
Do you expect your stabilizer to give same consistent performance to all the 1,000 buyers? Yes or no?
Yes, we need to give a constant performance, but
that is what you are monitoring in R chart.
Okay.
Every single lot should give same consistent performance. If R chart is out of control, one fellow will enjoy a good stabilizer, another fellow will struggle with your stabilizer. Okay. Chennai, some people will be happy in Chennai, some will be raising complaints.
Okay.
You are arresting it by ensuring that R chart is under control. Now, do you understand why we are asking you to monitor R chart?
Okay, sir. But here R
Wait,
chart
wait,
is
wait,
in
wait, wait.
control.
Let me complete. I'll come to the next question. Now R chart you understood, right?
Okay.
Now the next lot of stabilizer, let us say another 1,000 stabilizer, you are sending to Bangalore. And the third lot you are sending to Delhi.
Okay.
And now Chennai people got the best.
Okay.
You want the Bangalore people also to get the best?
Yes.
You want Delhi also to get the best?
Yes.
For that, you should also keep an additional eye on the X bar chart. If X bar chart is under control, whatever consistency and quality you achieved in Chennai will reflect in Bangalore also, will reflect in Delhi also.
Okay.
So that's why we want the within variation as well as between variation to be under control. Within Chennai, same performance. Within Bangalore, same performance. Within Delhi, same performance. And between Chennai, Bangalore, Delhi and other cities, same performance. Within lot, between lot. Do you understand now?
Okay.
And now look at the 8th lot. 8th lot, let us say it went to Bhubaneswar. Now tell me what will be the experience of people in Bhubaneswar. You have said you have sold 1,000 stabilizer there in Bhubaneswar. Now what will be their experience?
Bad experience because
why it happened? You failed to control the X bar chart. Do you agree now?
Yes, sir.
That's all. This is why you need to always monitor two things. One is central tendency, another one is variation. In this case, R chart and X bar chart. Hope it is clear to all of you.
Yes.
So sometimes we will get complaints in R chart and no complaints in X bar chart.
No, please understand. When the R chart is out of control, you should not plot X bar chart.
Okay. First we need to plot
R chart. See, within a batch, you are not able to achieve, within a shift, you are not able to achieve consistency.
Okay.
You are now not fit to compare one shift to other shift because within the shift there is no consistency. Why there is no consistency within the shift? Your operational procedures are not standardized. That is why there is a lot of variation, isn't it? You standardize so that that will appear first of all in the R chart. See, R chart is sample collected over a shorter time. Do you understand?
Okay.
If you are not consistent over a shorter time, will you be consistent over a longer time?
No.
So, first of all, achieve the short-term consistency. Shift-wise consistency you should achieve.
Okay.
One sample per shift is good enough, which means I have process, which means I have standardized the process. One sample I take one shift there. I am very sure next 8 hours the same thing will continue. You understand?
Okay.
Only when the shift is changing, operators are changing, there is a chance for variation. But in a company where the processes are not standardized, they will take sample every single hour. You understand? Because they are not confident that people will follow the procedure. Somebody can change anything they want, between hours. And so in those companies, you must take more samples. The sampling frequency will be very high. Do you understand? And obviously it will add up to your cost. Hope I have answered your question.
Yes.
So now you are a master of dealing with the control chart. And this is the formula, right? I don't want any of you to mug up the formula. Rather, know that there is a formula exists. You can always refer to it, always read to it, always do it manually once. Unless and until you ink your hand, you can't learn. I strongly suggest, I have already shared this, right? An Excel file. I share the data and expect each one of you to plot an R chart, plot an X bar chart yourself in a graph sheet. And then you will see that, all your doubts are clarified, right? And look at the formula and everything. When the subgroup size is 8 or less, you are suggested to go for X bar R chart. When subgroup size is more than 8, go for X bar S chart. When subgroup size is 1, let us say it is a destructive testing. You are bursting the balloons. And now I don't want to actually destruct too many samples, right? My company may not like. So I will restrict the sample size. Now subgroup size is 1. In that case, you can go for IMR chart. And all these things are for continuous data only. Continuous data means data that comes with some dimension. Here the dimension is millimeter. Similarly, if it is a dimensionless number, then you have to go for control chart for attributes. right? So this is the summary. You can read out. I'm sure you will be able to appreciate it, right? Because the material is already shared with you. You can read through all these things. And now that's it about the control chart for variables. Shall I quickly run through the control chart for attributes also? All of you are ready for it? Yes.
Yes, sir. Yes, sir.
But don't expect detailed coverage. I will give outline coverage, right? But definitely if you practice X bar R chart, all other can also be practiced easily. See here. Now when it comes to attribute data means you are now counting the defects. Attribute data is countable data. All of you agree?
Yeah.
Yeah, countable data, no dimension. Number of defects, 120, no units. It is just a number. It is not millimeter, it is not centimeter. And so the data is attribute. Now there is a difference between defect and defective. Can one of you tell me what is the difference between a defect and a defective?
One or two or three defects will be there in product, but it will not be defective. Product is defective means it fully failed.
Yeah. So defect and defective. A product can have n number of defects. Am I right? If I reject a product, now the product will become a defective product. Now, am I right?
Yes,
now,
sir.
as the head of operation, what is painful to you? Defective products is painful, or number of defect is painful to you?
Defective products.
Defective products.
Defective products. And now you need to plot P chart or NP chart. Suppose defectives are not at all happening. Absolutely, there are no defective items. Now you are an operation head. Now, what is your focus point? No defectives happening. But some products here and there, defects are happening. But still your people are making it up. And now, what is your pain point? Now you need to plot U chart and C chart. If you are moving from P chart to C chart and U chart, that means you have arrested the defectives. Somehow you ensured no defective pieces reaches the customer hands, but defects are happening inside the plant. All of you are with me?
Yes.
So if you are monitoring defectives, you are calculating PPM. What is PPM?
Part per million.
If you are monitoring defects, you are calculating DPMO. What is DPMO?
Defect per million opportunity.
Now, do you understand the weightage of PPM and weightage of DPMO? Yes?
Yeah.
So DPMO is looking into the details. PPM is whether rejected or not. That's all. I am not concerned further. Right? And now for defectives, you have P chart. Now subgroup size is an important parameter. If the subgroup size is fixed, you should go for NP chart. Subgroup size is fixed, which means every single shift you are going for sampling and you take 10 sample and come back. Now, what is your subgroup size always? I'm expecting a response here. You are collecting 10 samples every single shift. Now tell me what is your subgroup size? 10. Suppose if you keep changing the subgroup size according to the production unit, now your subgroup size is variable. All of you, do you understand the two situation?
Yes.
Irrespective of the number of units produced, if you always take 10 samples, your subgroup size is fixed. Now you should plot NP chart. But if the subgroup size is variable, you should plot P chart. Now coming to the attribute data, number of defects. If the subgroup size is fixed, you should go for C chart. You should go for C chart. If the subgroup size is variable, you should go for U chart. All of you understand? In P chart, we are monitoring percentage defective in every subgroup. In C chart or U chart, we are monitoring number of defects per unit. And accordingly, formulas are there. I don't want you to read out the formulas. because formulas are created to save your time. Use that, right? So when to use P chart, I have explained. And now there is a case. There is a case. A telephone service center want to assess whether its call answering system is under control. The total number of incoming calls, the number of unanswered calls were recorded for 21 days. Each unanswered call is defective. Now tell me, what is our focus, defect or defective? We are monitoring defective, isn't it? Each
Defective,
unanswered call is considered a defective. So your option is restricted to P chart or NP chart. Now, number of incoming calls, will it be a constant every day or will it vary?
Very.
It will vary. So go for the P chart. And now the P chart is plotted. All of you clear? And probably in one of the class, probably in the evening class, I'll show you how you can feed the data in Minitab and then all the charts can be plotted. Right now, are you clear? Why this control chart and how to read the control chart? That's a different story. Right now, it looks control. All of you agree?
Yes, sir.
Now again, procedure. You can read the procedure. You can do it manually. An inspection process checks parts produced for defectives. The total number of parts produced varies every single shift. The number of defectives were recorded for 24 shifts. The process is under control. Tell me which control chart you should use now. Easy question.
NP chart.
P chart.
P chart. P chart is the correct answer. Appreciations to Nega. Because you see here, defective is what you are monitoring here. Number of defective items every single shift. And every single shift, the produced unit varies. Out of 1,000, how many rejected? Out of 1,500, how many rejected? So subgroup sizes keeps on varying. So you have to plot P chart. All of you understand? All of you understand?
Okay,
Yes, sir.
Okay.
Now on the right side, tell me which control chart I should use. Read out the question and tell me. Any data missing? Any data missing?
Yes, sir.
Yes. What is missing?
Sir, the
Number
it's
of
not
samples,
number,
right?
yeah,
Yeah.
yes.
Number of samples is constant. Number of samples is constant. Very good observation. Because data file is not shared, that is missing. So number of sample is constant. Now tell me which control chart.
It would be NP chart.
Very good. NP chart. Look at the difference in NP chart and the P chart. Can you see the control limit also fluctuating in P chart?
Yes, sir.
That is because of the change in the subgroup size. Very good, very good. Now, another challenge. Look at this and try to find out. See now, accounts department problem. The number of defects in the invoice for every day is recorded. Look here, 6 Sigma is applied in a non-manufacturing department. Purchase department, accounts department, invoices, purchase orders, whatever is the report. And now tell me, what is this control chart you will plot now? Number of defects in invoice for every day is recorded. Is this process under control? Number of invoices every single day, will it be constant or different?
It
Different.
Different. And so we are going for U chart. You can see the fluctuating control limit.
Yes.
That information we have to add. Now on the right side, a process excellence team in a bank. I think we have one from Bank of America, right? The process excellence team in a bank inspects transaction. There are 7 opportunities for error in each transaction. I should give the name, I should give the account number, I should mention the amount. There are 7 opportunities. 100 transactions are inspected every day. and number of errors are recorded. Right? Now, what is the control chart? Now you are monitoring defects, but number of transaction is fixed. So it is
C chart.
That's all. Now all of you are now a master in what you call statistical process control. Right? This is the formulas. Now, how to read the control chart? What is that I have taught you so far? If a point goes outside the control limit, process is out of control. If the student is not coming to your class, he always stays outside the classroom, the situation is out of control. Am I right? As a teacher,
Yes.
you feel
Yes,
less
sir.
control over the students. Now, somehow you ensured all the students are inside the classroom. Like how I have all of you inside the classroom. But does it mean all of you are paying proper attention to me? You need to switch on your camera now. Now I am adding a condition. All of you have to switch on the camera. If you switch on the camera, I am checking another thing. Not only checking whether you are attending or not. Over and above, I can also check whether you are listening to me. Are you paying proper attention? Or are you discussing among yourself? Or is there anything happening even after sitting in the class? So you can add on conditions, right? So the first condition is outside the control limit, which is very easy. But second condition, look at the condition now I am putting. Continuously 9 points in a row on the same side of the center line. Can you see that?
Yes, sir.
What is normal distribution? Symmetrical, right?
Okay,
But this
yes,
is
sir.
one-sided.
Yes, sir.
How long I consider the process as going in a normal manner? 9 points are continuously getting plotted on the below the center line.
Yes, sir.
This is making me to think. Of course, my team might think I'm mad, but I'm not. I'm actually thinking correctly. Am I correct or not?
Yes.
Everything is acceptable only because it is too close to the center line.
Yes, sir.
Everything is going well, but then also I am trying to find fault, but I'm not a fault finder. I am a statistician. In my opinion, continuously, if everything falls below the center line, it is something against nature. I want to know what is that something. Clear?
Yes, yes.
Now, third point. What is the problem here? Problem is 6 points in a row.
Right, sir.
Always, when you are not able to understand what is happening in your business, open the chapter normal distribution. Just read it once. 68% of the points should be inside your 1 sigma limit. Am I right? Can you see 1 sigma line here?
Yes, sir.
Yes.
95% of the points should be inside 2 sigma line. Almost everything, which is 99.73, should be inside 3 sigma line. This is control limit. This is warning limit. This is 1 sigma limit. Based on the normal distribution only, we are creating rules. People might say, no, rules are come from Western Electric Company. No. They have generated it, based on the natural behavior. So now continuously 6 points moving upward. Instead of alternating up and down, it is moving upward. There is a pattern. There is a trend. Can you see a straight line pattern? Can you see a trend is moving upward? If I don't react, this may take all my products outside control limit and then customer complaints will start happening.
Yeah.
So we don't wait till the failure is happening. We even react before that. That is why Six Sigma is considered a proactive approach, not a reactive approach. People who are trying to use Six Sigma as a reactive approach may find it difficult to understand what Six Sigma is telling. But people who are trying to use Six Sigma as a proactive approach will find each and every tool extremely helpful. All of you understand?
Yes, sir.
Otherwise, see.
Sir,
Yes.
sorry to interrupt you again. Like those dark black lines, they are the control limits, right? UCL and LCL.
Yes, UCL, LCL. Yes.
Okay.
Yes.
Okay. And our main goal is to just put a halt into this so that so that this 6 can't so that the 6 cannot exceed the control limits, right?
No. Everything is inside the control limit only. But I am still I am still figuring out an abnormality here. Because continue, see, suppose I conduct an examination, 6 of you are getting exactly same mark. Can I not doubt you?
Exactly, yeah.
That is, all of you have scored pass mark. That is good for me. But still, how can all of you get the same mark? I see an abnormality there.
Yeah.
Right?
It may be possibility of cheating.
Exactly, right? You should not be cheated. That is why we are teaching you. Right. And now 14 points in a row, alternating up and down. Alternating up and down, randomness required. But occasionally it should cross warning limit. Do you understand? It should cross 1 sigma limit. So instead of that, see anything, this is a cyclic pattern. When it is continuously alternating up and down, it is cyclic pattern, right? So this can also be considered an abnormality. Please understand, these are matured level of looking at abnormality. Unless and until you know the subject of control chart, you know the subject of normal distribution, you can't talk in this line. You can still consider this as under control. But if your process, you have standardized your process very well, and you have made a lot of improvements, and now this will start becoming visible to your eyes. Till then, it may not be visible. And here the problem is 2 out of 3. 2 out of 3 beyond warning limit. What is the percentage? What is the probability for a point to appear between control limit and warning limit? Can one of you answer this question based on your knowledge of normal distribution?
About 2 sigma warning limit.
Between 2 sigma and 3 sigma, what is the probability for a point to appear here? What is the probability for a point to come inside 2 sigma? This knowledge is very, very important. Otherwise, connecting the dots will be difficult. Probability for a point inside 1 sigma is 68%. For a point to inside the warning limit is 95%. So what is the balance?
So
how much is the balance?
4%.
4.5%. And 2 out of 3 is much more than 4.5. I cannot tolerate. Understand? 2 out of 3 is how much? 66 or 67%, isn't it? Where is 4%? Where is 67%? So I start doubting it, right? Similarly here. So these conditions, if you are able to appreciate it, use it. If you are not able to appreciate in your process, don't use it. Because my son is not at all obeying me. For me, looking at the mark itself is wrong. I will make sure he is first obeying me. Only when he obeys, then I will look at mark, and he is not at all passing. First, I will see whether he is passing or not. Now he started passing. Now I will look at his mark. His score is below 80. Now I will target above 80. So gradually only you can come up to this level, not straight away. If he is not at all obeying you, you are advising him to score 100 out of 100. He will never, put effort, honest effort. So same is the situation, right? Similarly, 15 points in a row within 1 sigma limit. This should not be tolerated. See here, too much fluctuation. The amplitude is too high. All of you understand control chart?
Yes, sir.
Thank you very much. This is about control chart. Now, if the process is under control, it is giving you a signal that you can conduct capability analysis. When to conduct capability analysis?
When process is under control.
Under control. Your child has become obedient. Now he is ready for the counseling. You can call him and then you can give him the advice. He is going to follow. But if he is not having the patience to obey, first make him obey. Right? So capability analysis we will discuss little later. So I stop.
Okay. So before before proceeding, I just have one question. Like, since you have just given one example of like 15 points in 1 sigma level. So what you are trying to say that if all the responses comes within 1 sigma, like within 1 sigma or 2 sigma, for example, if we have 15 outputs within 2 sigma or 15 of outputs in 1 sigma, like the majority is, if it is within a particular sigma, then also it will be, then you mean to say that
I already told you, if you are not able to digest the added condition, you can ignore it. But now how the condition is created? Totally how many points there? Maybe about 20. So 15 out of 20 is how much? 15 out of 20 is how much? 75%? Yes or no? 15 out of 20 is 75%, isn't it?
Yes.
But generally, our understanding about normal distribution is 68%. Am I right?
Hmm.
So if you think, sir, 68 and 75 is too close, I am okay with it. Leave it. Clear? But then, these are rules created by someone. The Six Sigma is created by Motorola, and Motorola is different, your company is different. You can change the approach and customize it for your company and for your scenario. And they said, target is 3.4 DPMO. Some company are saying 0 ppm. Isn't it? So slight changes will be there. You don't have to worry about it, right? So 15 in a row is an abnormality according to the theory, but it may not be abnormality according to you. You can follow it, right? But definitely when it goes to the level of customer, yes, for everyone it is abnormality. All right.
Sir, one thing, whatever it is best one, we can take it as a benchmark. That is a global norms. Na?
Correct.
Likewise, we need to take the Motorola is generated the Six Sigma. We need to take it as a benchmark for all the industries, whatever it may be. It may be a ice cream manufacturing industry, or else it may be a heavy vehicle industry also.
Correct. Correct. We should always do benchmarking. See, something good is already happening. Why not we, go beyond it? Isn't it?
Yes, sir.
If
Yes,
there
sir.
is a reference available, a benchmarked performance available, you must strive to go beyond it. So, which is called continuous improvement. Okay. So I just stop here. This is about the statistical